Now we will look at the example. Using class vector as a private base class for derived class stack. In this case, vector operator may be reused as an implementation for the stack push and pop methods. That using private inheritance ensures that the operator does not show up in the interface for class stack. Often a better approach in this case is to composition has a rather than decent or is a relationship. Class inheritance can be used in two primary ways. They are, first one is interface inheritance and the second one is implementation inheritance. Now we will look at regarding the interface inheritance. A method of creating a subtype of an existing class purposes of setting up a dynamic binding. Circuit is a subclass of shape. A birthday is a subclass of a date. Now we will look at regarding the implementation inheritance. A method of reusing an implementation to create a new class type. A class stack that inherits from class vector. A stack is not really a subtype or specialization of vector. In this case, inheritance makes implementation easier since there is no need to rewrite and debug existing code. This is called using inheritance for reuse. The dangers of implementation of inheritance. Using inheritance for reuse may sometimes be a dangerous misuse of the technique. Operations that are valid for the base type may not apply to the derived type at all. Performing a subscript operation on a stack is a meaningless and potentially harmful operation. In C++, the use of private base class minimizes the dangers. If a class is derived private, it is illegal to assign the address of derived class to pointer to a base object. On the other hand, a consumer or has relation might be more appropriate. Comparison. This graph shows how the object orientation, static or dynamic typing, inheritance, method overloading, and access control are used in C#, Java, and C++. In Java subclass, you can override any method of the superclass. The method that is to be called is always determined at runtime. For an example, if you write the code like this, if you create a new instance of a child class, when you call the sayHello method, it is always the child one that will be called, no matter what is the declaration class is. So you can treat an instance of child as an instance of parent, but the methods called will be the ones from child. In C#, things are a bit different. C# language needs to be told which method can be overridden and which method overrides. So to have same behavior as Java, C# code has to look like this. Overriding. If the virtual and override are omitted, then it is the parent's method that is executed when the child object is declared as parent. In C# specification, there is a clear explanation on how it behaves. In a virtual method invocation, the runtime type of the instance for which that invocation takes place determines the actual method implementation to invoke. In a non-virtual method invocation, the compiled time type of the instance is the determination factor. The superreference. In Java, the method called will be determined by the instantiation class, while in C# it will depend on how the class and the calling code is written. C# gives you much more flexibility, but it is more complicated, and the capacity for a class to override a method is determined by its parent class. With Java, you lose the ability to call the parent's method, but it is that very useful. Thank you for watching this video. Hope you got a better knowledge on how the inheritance is implemented in C#, Java and C++. Thank you.